Hey guys, hello. Welcome to today's, should be okay. All right, that's cool. Welcome to today's class. We're continuing with variables again. So this is basically the way we'll be doing it. Milestone 2, try 3. We'll start with that, and then we'll walk through the solutions. Then we'll have a break. After the break, we'll review variables. I'll give an example of a cup of tea, variables and functions called by value. And then we'll start to apply C coding for falling objects. We'll work together as we apply that. Then I will give you a chance to try to apply it to the optics formula to go from pseudocode to the real code. And then hopefully I'll have time to demo that. And then for homework, you'll be working to do the root finding code, and then we'll take that up next week. So we'll start off with milestone 2, try 3. So make sure you are sitting alternate seats. If you've already done it, you can do it as practice. Again, if you've already passed it. If not, then we'll be using it, we'll be grading it. Okay, so please make sure you're separated by one seat from the people next to you. Okay, and then me and Raheem and myself will be handing out the milestone tests. Okay, the milestones. Okay? All right.
For the helping part, for the mentoring part, they cannot help actively.
No, during the test you cannot. If you are mentoring, you're not helping during the test. If someone has helped you in preparing the milestone, you may write their name down on the milestone. Okay. Okay, let's go back to download our Blackboard. Our tools. Okay, download. Open. Okay, let's get started. I'm going to do it. I'll probably try to do it. Okay, I get it. Okay, I've got this on this side. Okay, I can't really show it very easily. Okay, trying to figure out if there's any way we can show easily. Okay, so let's start. The purpose of the program, as you can see, is to find the mean, minimum, maximum of a group of numbers, which is a common problem. We want to read 100 numbers and check this. Okay, the last number, okay, here's our implementation. Okay, all right, that's initialize. Okay, let's start. Okay, and I got to move my thing across. Okay, so, okay, I want to use, it's this guy we want. Okay, not variable pointer, it's UML. Okay, we start our routine. Enable editing, okay. Okay, we start. We have our first action, initialize everything. I'm just going to initialize like min equals 100, something that's too big, and max equals 0, etc. We know all the initialization stuff here, so I'll just put that note there. And don't, okay. After initialization, our next step is going to be read in the next grade. Okay? Read. So read grade, okay. And we're going to have to, then after that we'll start a loop. Now there's a few ways of doing these things, so this is not the only solution. Okay, if -1, go to 9. Okay, so we've got a, all right, obviously we've got an if statement, so we're going to have a triangle. So we need to check to see what type of condition is this. Is this a loop or an if not? So this is a loop, okay? So we're only going to need one triangle, okay? We don't need, one diamond, sorry, okay? Increase count by 1, add m to sum, do all these 4 things. Now, can we do these things in parallel or not? Yes, we could increase count by 1. Yes, we can add m to sum. Yes, we can do this in parallel. Yes, we can do this in parallel. Okay, we can do all these things in parallel. Okay, cool. Okay, so we can just we can bring in one of these parallel bars. Okay, so I'm going to throw in a parallel bar. Okay, what can we do in parallel? Okay, let's start to do everything in parallel. First thing we can do in parallel is to increase count by 1. So that's the simplest way of writing that is count plus plus. Okay, semicolon, increase count by 1, add grade to sum. So that's sum plus equals grade. Okay. All right, what else am I checking? I've got an if. If m is greater than max, max equals m. Okay. Okay, so I'm going to have an if. And if it's greater than, I'm going to have to do something. If not, I'm going to do nothing. So let's just actually write this little if n thing together here, because again it's an if, so it means I've got to have a pair of them. Okay, I can't just have one. And in one case, I'm going to put max equals m. Read grade. I'm going to call read m. Okay, read grade m. M, that makes it shorter. Okay, max equals m. If not, okay, let's just do the whole if structure here. So this is going to go to here. This one is going to go to here. And okay, the other option is it's going to go straight. Okay, let's move them over, make it simple, because there's nothing going to be done if it's not true. I don't want to do anything here. So that's going to be this little structure. Okay, the other cake, so this would be, I better put this little note. So I've got to put a little note only on one. If m greater than max, I will follow this route. Otherwise, I'll do the other one. I'm going to need the exact same statement for min. If m less than min, less than, don't change please, min, okay, then min will be equal to m, okay, and I can do, okay, let's now put all these guys in a parallel now. Okay, E goes from here to here, and from here somewhere else. Probably I'll put him down here somewhere. I'll move this min over here somewhere. Now I'm gonna do the code 2 different ways, so you can see different directions I could do this. Let's make this bar long, so I got nice lots of room. Group. Okay, and I'm going to need another arrow to come down D, so this can be done in parallel with this guy. This guy shoots over to here and in parallel there. This guy is going to go to here. And then we got to join everything back together again. So I need a D, another one of these guys. And my flow will then come out of each of these guys. There. This one's coming to there. This guy is coming to there. And this guy is coming to there. Okay, and once I've done everything, according to my thing is, okay, I need to go back to go to 2 and go to the next grade. Okay, so I'm going to have to go back to 2. I'm going to have to swing all the way over there. So let's get this nice arrow done. He's going to have to come in right here between the initialization part. This guy got to go around my thing somehow so I don't bump anything. Come down here. Come across here. Don't have to go too far over, I guess, and I just need a bar going down. Okay. And then the other case we haven't done is what happens if we're at the end. We don't have to go through this loop at all. Once we've got -1, we have to handle this, and I'll need a little note. M equals -1 will send me this route. Oh, come on, higher, okay. I'll move them out that far. Okay, M equals -1, we're just basically ending the program. I'm doing my 1 step, 2 steps, and an end is going to be coming here too, so maybe this is too far over. Okay. What am I supposed to be doing now? If I can remember, I'm going to be calculate average equals sum divided by count, print min, max, and average. Okay? AVG equals sum divided by count. 2 lines, okay, and then print, okay, and then end, okay. Now, okay, D. And this guy needs to go to here, and this guy will come back to my endpoint. Okay. So there's my UML. This is using parallel. Now, I don't have to use parallel processing, right? So this is one solution. I'm going to save it right now. File, save as. I guess I'll save it as downloads. And I'm going to call it black. Okay. M2 parallel. Okay, and that's not, okay, if we don't want to do parallel, I can get rid of these guys and just start to link them together, okay? This guy will then go, let's do this first. So this is basically a decision that you actually start to make when you're actually coding. What do you want to do in what order? The sum, and then this guy will then go to here. Let's move you down. Okay, and maybe I'll send this guy to back to here, although delete. Okay, I'm gonna have to move this whole thing down so he doesn't cross. There, that looks okay. And this guy I'm sending into here. Okay, fair enough. Okay. All right, so that would be a case. So basically, if m equals -1, I end the program. Otherwise, I increase count, increase sum, check to see if I'm less than the min, then check to see if I'm less than the max. Okay, now, this is, okay, file, save as, downloads, okay. sequential, I'll call this sequential. I'll try to post these online for you too so that you can get an idea what they are. Let's see, mistake. Common mistake for a lot of people is logic. Ungroup, okay. Basically not having two sets. In this case we have going okay, this is the problem right here. M greater than max, going one way. M less than min, going the other way. And we're coming in with this thing coming down. So you're coming into this, you do this, and you've got, okay, if this is true, then I'll do something here. If the others, and then joining back together again. Sorry, I just put them back here. And there was this guy. This was the main logic mistake that most people made. Okay, and then they join back together. I'll try to click join. Come on, join. Okay, sorry. This can go to here. This just goes to here. This goes to. So this UML is okay. There's no problem with the UML. There's just a problem with the logic. Okay, they both come in and then we come out again at the end. Okay, there we are. This is the. Okay, the problem here is what happens if M is not greater than max and not less than min? If let's say if the maximum is 80, the minimum is 20, and M is equal to 50. M comes in 50. This is not true. This is not true. Your program crashes. Okay? Because there's nothing you don't know what to do if that's not the case. Okay? You've got the cases. There's nowhere to go if M is not greater than max or less than min. And that is probably so that's the main error that most people have, is this little problem right in there, trying to do this problem right in here. Okay, so just note that, so it'll be some code looking like this, and then your code and people's code continued on like this. So this would probably be the most common error that we actually had. Okay, it's this code. And the UML is correct, but the logic is not, because if M is, maybe I should put that in a box. If min is less than M, less than max, crash. Okay? And that's, okay, okay. File save as, downloads, I'll call M2 error. Okay? So that would be the common logic error that we had. I think we can now break for 10 minutes, and then we'll come back and continue after the break with looking up, going from UML to pseudocode. Okay? All right. I mean, not from pseudocode to actual code. Let's come back and we'll continue on as we move from UML to pseudocode. Okay, so we're now in our second hour. We'll be looking at UML to pseudocode, and we'll start to work. Okay, oops, wrong one. Okay, reviewing of variables, and then the cup of tea. Okay, and then, okay, great. Okay, so let's quickly review the variable stuff that we talked about before. All right. By means of review, first of all, we have two key types of variables that we are interested for dumpers. One is fixed point, one is floating point. Within these two types of variables, the size is how much memory we're taking. Once we know this, we can then start declaring, initializing, and using. Okay? Key point, a variable is a container. It's just a container to hold something. And whichever type of container depends on what we want to put it in. And we have two choices. Basically, just a garbage. And we have two main types of containers that we put things in. One is a fixed point container. One is a floating point container. William, question? Okay, we have these two types of containers that we can work with. Now, within each type of container, we have different sizes. Basically, you can see there's basically, each type of container has 3 different sizes. Basically small, medium, large. So 1 byte is a small container for fixed point with car, which can have 8 bits. For floating point, there's no such container with only 8 bits. For floating point, there's the smallest container has 2 bytes. 8 part of the bytes are used for the mantissa. The other half of the bytes are used for the exponent. Both types of containers have a 4-byte size container. For fixed point, it's called long int. For floating point, it's called double. Generally, we will always use only these. For numbers, we try to use long int or double. Unless if you're using a Windows system or a modern computer, you are either 62 bits or 32 bits. Putting something in 16 bits doesn't make any sense. Okay? So, it's only useful for Arduino, the smaller sizes. Okay? So we can basically do everything we want with long int and double. Okay. One is a fixed point, one is a floating point. Oh, must be connected to the wrong one. Okay, we see the size, and here we can see how the difference in storage. On the right side, I'm storing 40. Basically, it turns on a couple of bits, one for 32 and 1 bit for 8. Okay, I'm going to show my pointer. 1 for 8. On the other side, if I'm floating point, 1 is for the mantissa, 0.4, so the 4 is stored here, and a 2 is just stored here. Okay, so it stores in half of the memory for the mantissa, half for the exponential. Okay, now I'm going to try to. Okay, we looked at now a simple program in which we talked about the 3 steps. We start with where the function prototypes are. Here's main. We declared a long int and, declare. Initialize, which is puts a value into the container. Initialize. Make use of some containers. And storing and making use of it. And then finally printing out our final answer. We worked through this code, you compiled, linked, and ran it. And we went through a whole bunch of questions. The steps for variables, you must declare, initialize, use. Let's echo. Declare. Initialize. Use. Good. Thank you. All right, appreciate the enthusiasm. Okay, declaring variables. These are the way we declare them. Car, the type, and the variable name. The type and the variable name. In yellow are the ones that we are going to be using in this class up until we get to records. At the very end, we'll have a new type, but that will be right now. Okay? We can initialize variables. After the declaration, in other words, we've already declared it. We've already declared and as a container. Now we put 6 into and. In this case, Without that, hang on, something's wrong here. Okay. All right. Never mind. We'll forget that step. Okay. Here we are, double gym. We actually put 0.53 into the container. We declare the variable gym. We put 0.53 in. In this case, after the declaration, we first declared it, then we put it in. So we can put it all in one line. Sorry about this one, this is wrong. Okay. All right. How do we do a computation? Basically, 2 times n plus su, this line. This is the assembler code that actually does that job. So it takes the value that's in the memory location n, puts it into the CPU R1. It then multiplies by 2, which is a left shift operation, to get 12 in R1, and still has 6. Next, it loads the value of su into R2. Okay. Now it's going to add these two values together and put the result back into R1. Okay. And finally, it's going to move the value from R1, put it back into container N. Okay, we mentioned these are the various arithmetic ones. How we do addition is plus, take about and subtraction, multiplication, division, finding the remainder of a number, adding 1, subtracting 1. We talked a little about precedence. Inside brackets are first, outside multiplication, and then placing them into container A. So on the left side is the container you're putting something into. On the right side are the containers you're taking the values out of. Okay? So you're taking the values out of the containers on the right-hand side, doing the operation, and placing the answer into the container on the left side. We talked about this key statement fprintf. So first of all, we have the function name, fprintf. That's a prototypes in SDO.h. Then we have where we want to write it. Then we have what to write, and long fixed decimal point number, a fixed decimal point number, it can be an integer or char, or a long floating point number double, and where we want to, where the information we're going to find it. Please note, small l as in long, not the number 1. This is a common mistake, typing 1 and not L. And it's hard to find. Okay. So we then look through this. Let's now we'll move on to today's lecture. Okay, we finished summarizing. So a cup of tea. Tea making, how we work with functions and variables into functions. Okay. This is making tea. Okay, we start off with a couple of comment lines. My thing is how to make tea. This is a program. Okay, so here's my function, help make tea, and I have a function main here. Main, I have a variable cup, and then I want to make tea. Okay, so I've got a variable cup here. I'm calling function make tea now. I'm going to need some, to make tea, I need some water, so I'll container to put my water in, a container to put my tea bag, a container for my sugar, and a container for cup. Okay, note these two cups are different. They're not the same cup. They're not connected. Okay, I'm going to have 6 ounces of water. I think I'll have 1 tea bag. 0.4 grams of sugar. Now I'm going to place the water. I'm going to take the water and the tea bag and put it into my cup. Okay, basically what we're trying to do. Okay, they both go into the cup. Now I add some sugar, and this is giving my everything is in my cup, my sugar, my tea, and now I'm going to hand back the contents of the cup. I'm going to pour it into the cup that main has. Okay. Okay, I'm not giving it the cup back, I'm just pouring the contents into the cup of main. Okay, so I've now poured it back into the cup in main so we can see how the variables are being worked out. Okay, and then I return, once this is returned, this disappears and then this disappears. Okay, so for variables, declare, initialize, use, and with functions it was prototype, call, definition. With these two concepts, we can now start to move on. Okay, now let's go back to we're going to now work through something together. As soon as I get our location, where's my, okay, there's my portal, I don't want, okay. On the portal, there will be a link to Google Meeting, and we're going to start with the Google Meeting now, so that you can see on the screen what I'm doing. You'll put that in half your screen, and the other half you'll be able to work along with me, okay? What we're wanting to do is to move from, okay, so you should be able to open with Google Meeting. Like I got in my portal, I got Google Meeting link. Okay, I will link to my Google Meeting. No, I don't want to use microphone and camera because I don't have microphone and camera working. Okay. Okay, so please do this and then optimize this so this is on one side of your screen. And okay, you see, so you're going to want this on one scribe. I'm going to let you go now. All right. So please go and load and enter into the meeting, and I'll get myself set up here too. Okay, so first thing we want to do is to, you're going to want to, okay, I'm going to switch my screens on the halves to, okay, I know I want that there. I want Notepad on one half. Okay, get my Notepad on this half of the screen. Okay, so if you're looking through the stuff, what we've got now here, you can go to ANSI index. What you want to do is we're going to go from the pseudocode to make our first ANSI code from the pseudocode. All right, so that will be on, you know, SDBA, www.sdba.info, right? Going from SDBA programming from problems to UML and C. That page, the basic C index. Yeah, please, from basic C index, please go down to G3com.c. You're going to want to take that and copy it into Notepad. Okay, so I don't want you wasting time copying this, we want to just copy it into Notepad. So, okay. Okay, so we're copying this into Notepad. You'll click on the link. You will get some pseudocode that we did before. We will then place it in a Notepad. Okay, so you're copying the pseudocode, placing it in a Notepad. I'm going to make it nice and big. File, and then you can save it into SDBA. I'll call it G4float.c. Okay. Oh, what happened to my G4float.c? I lost it. Did I? Oh, here it is. Okay, here we are. Okay. Okay. All right, so okay, as soon as we're at this point, when everybody's at this point, we'll then continue on. Okay?
Professor.
All right, let's start moving on. Okay, so I'm looking at this code. Okay, I want to convert from pseudocode now to C code. Okay, I'm using G3COM. These two I don't have to make any changes to because they're just comment codes. Now I have my prototype for deriv equals, so I have to now make it a correct prototype. Okay, so I've decided that I'm going to have to say, okay, deriv is going to be of type, I have to decide what type do I want it to be. I think I will make it double. Okay, so it's going to be double C dy dt. It's going to return a type double, and it's going to take a double, I don't know, it doesn't really matter what I put here for names, double y2, double t1, double t2. Okay, so I've now, oops, my mistake. There, so I've now got my prototype for this guy. I have to put in my prototype, maybe I'll make it bigger. Can I make it bigger? No? Yeah, okay, so there it is. So I already have my prototype from John Input Library for Git Float Prompt, so I don't have to worry about that. So I've converted my prototype here. I now need a prototype for t-average, which I'm going to, t-average is, I also want to be a double. So I just type double C mean, and I'm going to receive one double A and a container, a double container B. Okay, so this is basically, this will then complete my prototypes, and the other two prototypes I don't need. Okay, so please make this conversion in your program to convert the pseudocode prototype into C code prototypes. Okay, make sure we're okay on that part. Once we've done that, we'll then start to work on the next part, the call parts. Our prototype should now be functioning. Let's now move on to start with the next part of the conversion, the calls. Okay, before I need calls, I'm going to have I have to declare remember, declare variables first, then I can use them. So what variables do I need to declare? I'm going to need a double h1, t1, h2, t2. I have a v here, and I've got a t-average here, or a dy dt or something. I don't know why it's, maybe I'll call this dy dt. Anyways, okay, I'm going to make this dy dt. It's probably a mistake in our prototype. I'm going to make a dy dt as another variable, and I'm going to want a t-average as another variable container. So I'm making 6 different containers to hold things. All right, so I've got my 6 different containers that are going to hold things, and I've declared that. My next thing is I'm going to have to start to write my function call for get float prompt. Okay, I know get float prompt is in jinlive.h. So let's go to jinlive.h and see what I need for it. File, open. Here it is, jinlive.h. And what I need is, it's going to return a double. That's what I want. But it needs a character prompt. Okay, which means this car star prompt is called a string. It means English characters. Okay, so I know what I want the structure, so let's go back to get float. Based on this, my first one will be, let's get H1 first. H1 equals get float prompt. Okay, and I'm going to get my prompt input H1, the message I want to give. Okay, so I'll just put that into here. That will be the message I want to give. So H1 equals get float prompt input H1 is the C code to do that. Okay, you can now similarly, let's move to the next one. It's also using get float prompt for T1. I will replace this with my input T1. Okay, and okay, so I've got H1 and T1 now being input. My next step is I want H2, so I'm just going to, okay, H2 equals get float prompt. Maybe I'll put my prompt input H2, semicolon ending my line. And finally, I've got one for T2, so I'm going to T2 equals get, oh, I don't want to type it again, it's already there. Okay. Okay, so now I've used these guys. I've now got it, I've converted these functions for the inputs have all been redone into C code. Okay, I'll just make sure everyone give a couple minutes for you to do your typing. Okay. All right, let's continue on. Okay, my next one is dy dt to do the calculation. So dy dt equals c dy dt. What does it need? It needs h1, comma. It needs h1, it needs h2, it needs T1, and it needs T2 to do the calculation, right? So it needs, according to my prototype, I have to give it four things, y1, y2, t1, t2, so I just give it h1, h2, t1, and t2, and it's going to calculate my derivative for me. So when I'm writing, I don't think about how the functions are working, just what needs to be put in. Next is to calculate t-average. And this basically is already written already, so I don't have to do anything here. It needs t1 and t2. Okay, there we go. I just get rid of the brackets. And my final statement will be call fprintf. Now, I want to print dy dt and t-average. So, to do that, I would basically, I look on my cover of my book. If I want, I can then see from the cover how to write fprintf. It's a standard SDIO function. We talked about it already. Where's my, sorry, I don't want to do that for you. Sorry, you'll keep that up for you for a second while I find the right page. Okay, I want to call fprintf, do this, calculate these two things, so I quickly check. Huh? I don't know why it's going blank on me. Okay. Where are we now? Okay. Okay. I'll forget trying to do it. That doesn't seem like they're cooperating. Okay. So let's quickly look. So fprint. Oops, wrong one. So fprintf requires standard out, a format, and then what we want to print. So in this case, let's just leave this guy here so I can. Okay, so fprintf needs this, fprintf standard out, format, and then the variable names. Okay, so I will change this to fprintf standard out. Okay, you can see it's even giving me, it's telling me how to do it too. Constant character star format, file stream. Okay, so the stream is standard out. The format, what do I want to, I want to output t average and dy dt. So maybe I just put t average equals percent LF. And dy dt equals percent LF. Okay, there's my formats. And TAVG I'm going to put here, and dy dt. Okay, so I've now completed all the calls and my main program is complete. Check to make sure that looks okay, so you can, don't. All right. Okay. Okay, I should save it to make sure I don't lose my work. Okay, our next step will be now to write the function definitions. So for writing the function definitions, the most straightforward way to do it is to first of all copy the function prototype, because the definition should be the same as copy the function prototype line, bring it down here, and instead of having a semicolon, you end with this guy. Okay. It has inputs, okay, and it's got a formula. So I need to declare, it's got a new variable deriv that I'm not getting here. I have all the variables I need, y2, y1, t2, t1 are here, but deriv is not, so it's something I'm calculating, so I better I need a container for it. So I'm going to create a container for deriv. Then I've got my formula here. I'll just copy it, add a semicolon on the end, and then I want to return deriv. That's what I'm trying to calculate. Remember, the output is deriv, so the output is what I'm going to return. And I close my function. So now I've completed this is the function definition for dy dt. And finally we'll do the function definition for cmean. Okay, cmean, I can just copy it from here again, from the prototype. Okay, I've already got the input. I'm going to have to create a new container, double X. I'm going to want to put in the formula. And I'm going to want to return X to the calling program. Okay, so this is basically I completing of my program. I should shrink the size so you can see everything now. The whole program at once. There's the whole program that we have. That should run successfully. Pardon?
Here.
Okay, we'll get it will, it's on purpose. Okay, so we'll see that. So let's now try to run it. I will try to run my program. I will go to, I saved it SDBA, ANSYS, more info, okay, I'm sorry, I forgot that, okay. I'm going to ANSYS, I'm clicking on it, more information, run anyway. Okay, I now have my command window is now up, and I will try to run it. GCC minus C minus wall. It's called G for float.c, and I get an error. Okay? So this I got to start to debug my error. Okay? It says my error is on line 21. It's character 9. Okay, line 21. Character 1, 2, 3, 4, 5, 6, 7, 8, 9. It's somewhere in here. Okay? Oh, I have spelled wrong. Okay, so I'll replace this with an R. Okay, any other? I will try to compile again. Only check for one error at once. Don't try to worry about a second error. Fix one thing at a time. I will try to compile again. Oh, I forgot to save it. Oops. Okay, so I need to save. All right, I will try to compile again. Okay, he compiles okay. Minus O, G.exe, G4 float.o. Okay. Oh, I did, okay, you can see there's a problem again. What have I forgot? I forgot to, remember, I did not put the other G4 float.o, and I called JInLive function, but I did not include it when I did my linking. Okay, now he's happy. I can now run H1 42.5, 42.5, T1 0, H2 39.5, T2 0.78, and I get my output as minus 3.84. And I should then check that with my hand calculation from before. And I think it is correct from my hand calculation from before. Okay, and we'll take break here now for 10 minutes, okay? Okay, so go to page 30 in your workbook, and you'll try to fill in this, and we'll put the stamp there when you finish it, okay? Okay, hello again. Oh, oops. Okay, please go to page 30 in your book. Page 30. Use the program to calculate for those numbers that are missing in the table that are in blanks in white. Don't fill in the gray stuff. We only want to fill in these numbers into the white stuff. Use the program to calculate these numbers. Okay, and then when you finish, the TA will give you a stamp on that. Okay? So please use your program just to do the calculation, and then we'll move on to our next step. Okay, we're going to get started on the next thing, and I'll just show people who have. We'll work on people with others who have not yet finished, but we'll try to give you the next assignment to do. Right now, I'm going to share my screen. I hope I'm going to share it. Okay. So I want you. I'm going to walk you through this first of all. Okay. So this is going to. Oh, sorry. Here we are. This is calculate going to the floating. We're going to look at this code now, and then I'm going to give you an assignment to do, okay, to work on continuing on. Okay, so you can download this yourself and look at it from the website too. If you want to hear more what I'm, okay, do I have I got to see my recording. Yes, I am. Good, okay. This is the one, I think. Okay. All right. So this was the pseudocode we had, and we basically have converted it. You guys have successfully converted it now into ANSI C code. And once you convert to ANSI C code, you've run the code, and we ran it for a few specific numbers using GCC. Okay, you need to use John in library, remember, and the Y. Okay, I just called it Y this time. And if I wanted to, I could use debugging to try to debug it if necessary. Okay, let's do some code analysis now. Okay, first of all, we have the first two lines with the info for the human reader, the program name, purpose, author, and version. The next couple of lines were to the preprocessor, some function prototypes. Okay, in other words, that's where they're located. Ones that aren't in this file. These are function prototypes that are in this file. And then main started. The real program started. First thing in main is created, and then we declare a whole bunch of containers. Y1, Y2, dy dt, T1, T2, and a T container here. Okay, actually it should be, we have T average in our program now, so, okay, so I contain these containers. I then call get float prompt, and basically what get float prompt does is it calls this function get float prompt. You inputted 42.5, it got saved into memory as 425 and 2. Okay, 425 is where how many places you need to move the decimal place, and this is the number. The next line got T1. And it stored 0. And some sort of a small number, e to the -9, you try to put in 0, because the computer, if you are using floating point, there is no 0 in floating point. Okay, there's no 0 in floating point. It's only approximately 0. Y2, 39.5, okay, stores into this container. And then T2 stored it into this container. So we have now things in our different containers. Now I called the function dy dt. So this dy dt calculates dy dt. I gave it these four numbers. 4.25 was put into its container. 395, 0, and 0.78 were all put into these containers. Next, it created a new container deriv to store what it calculates. it does the calculation, okay, and stores this number into the container deriv, and then finally it returns deriv to the main function. And once it's finished returning, it disappears. Next, we call cmean. Okay, cmean is called, and as you can see in cmean, basically it copies T1 and T2 into A and B. It creates a variable x. It then does this calculation to put 0.39 into x after the calculation, and it returns this value to the main program, goes back to this main program. The next line is fprintf, which is called, and it basically prints minus 3.85 0.39, and we finish the program. Okay, what we're going to do now is once you can look at this again if you want to see, but now you're going to download this program and do the exact same thing as what we just did, but this time I'm not going to show you the steps first. You're going to do it first, okay? And then probably at around 5 minutes to 5 o'clock, we'll walk through it for the last 5 minutes. So I'm going to give you 15 minutes to work on this, copy this from so copy this, right? You're going to copy it, right? Where's my thing? Copy it from, where did my, yeah. So you're going to copy it from, you basically know what I'm doing, right? You're going to copy this guy, put him into Notepad, put it into your Notepad, instead of this guy, save it as, file save as 03 if you want, okay, 03.c if you like, something short and easy. Okay, so you're taking this guy, finding him and just putting him into here, okay? I will let go of my screen and you can continue on. Okay, I'm going to take over your screens for a second. I want to walk you quickly through solution, and once you finish your own solution, you can, okay, I'll show you basically how I would work on it again. Okay, so I need my prototype, Control Z, I don't want to do that. Okay, so I get my, I don't want to overwrite.
You have to press insert.
Insert has gone bad. Okay, good. Okay. Double equation lens, and it needs double O, double F, and okay, I'm missing a space. You can see it did not change color because I forgot the space. Okay, and I want my prototype here. It's another double, and the function is cmag double O double I, and that basically completes my prototypes. I'm going to use Git, so my calls, okay, I have F, H, and O, and I accidentally typed HO here, so I don't really want that. Just H is okay, make it consistent. So I'm going to need a double F, H, O, and I also have an I here and an HI. I and an HI, that gets rid of all my variables. I've got all the containers I need. Okay, so I'm going to use git flow prompt to get my F. So F equals git flow prompt. I'll probably put something like F, okay, whatever I want to print for my prompt. This one, okay. H equals get flow prompt, whatever I want for my H. Prompt. And I'm going to also want, this next guy is O equals get flow prompt, whatever I want for my prompt here. O. Alright. I now need to convert to my calls. So this one's pretty straightforward. Just get rid of this extra stuff. It requires O and F. This one is actually calculating HI equals C mag O times H. Just getting rid of the comments. And I'm going to find the F print F, okay? Where do I want to print? Standard out. What am I printing? I'm printing 2 LF, comma, percent LF. I don't know how I want I, comma, HI, semicolon. Okay, my function main is now complete. Now I want to make my solve sub-functions. So the first one is this equation lens. It has the input, the O and F, okay. It needs to output I, so I need a container to hold I temporarily. I have my formula is here, so I'm just going to move my formula up. And I'm going to have to put in a multiplication sign. And I want to return I. And that's the end of this guy. And finally, I have to do my function for magnification. Which is going to be the same, double M. Definition is here. Oh, where's my no, the formula is here, not that. Formula, I want my formula. And I want to return M. Okay, this completes the function. So I will go back to you. So once you have completed this and run your program, homework is to do the same thing for root. But we will stamp, once you get your stamp, you may leave, okay? So just stamp the optics and then leave, okay? So whenever you finish stamp the optics, we'll stamp it and leave, okay? And I let go back to you, okay?